So we're looking at simplifying algebraic fractions. But before we go into that, let us recap on how we actually add and subtract fractions. So let's go back to our previous days in fractions. So when we have a fraction or two fractions that share same denominators, we normally take back one of the denominators and we will work the numerators according to the mathematical operation that we're seeing. So we will say 1 plus 1 gives us 2, and then we'll simplify this fraction and it will give us 1. Let's look at if we have, say we have 3/4, take away a quarter. So we will do the same thing, bring back one of the denominators and we just subtract the numerators, and that will give us 2. And if we should simplify this, we actually get 1. 27 goes 1 time and 2 into 4 goes 2 times, so this will give us a half. Let's say we have a half plus, say, a quarter. What would the answer for this be? Well, since the denominators are not the same, we could actually do both. We could actually try two methods. We could actually use the LCM method to actually solve this. So we could say, all right, the LCM would be 4. So if the LCM is 4, then we'll have 4, and we say 2 into 4 goes 2 times, and 2 times the numerator of that same fraction. So we'll get 2 times 4, 2 times 1 gives us 2, and then we say 4 into 4 goes 1 time, and we take that 1 and multiply by the numerator of that same fraction, and that will give us a 1. So since this numerator is actually sharing the same denominator, then we just bring back the denominator and we just add the numerators, and that will give us 3/4. So by recapping this concept, then we should not have any problem with simplifying algebraic fractions. So let's look at the first one. If we have 1 divided by 2 plus, let's say, a, so let's say a divided by 2. Well, since the numerators are not the well, since the denominators are the same, we just bring back one of the denominators and we try to add the numerators if they are like terms. If you look at it, we have a constant and a variable. A constant and a variable, they are not like terms, so we just bring back them in our answer. Let's try another one. If I have 2x divided by 2 plus, let's say, x divided by 1, or let's say 2. Since the denominators are the same, we take back 1, and since the numerators are like terms, we'll just add the numerator. So we say 2x plus 1x gives us 3x, and that will be our final answer. But let's say the numerators are not the same. So if the denominators are not the same, let's say the denominators are not the same. If they're not the same, then we can actually do the LCM method, or there's another way we could actually solve these fractions. What we could do, we could try to model this fraction or this denominator so that it actually is the same number as this denominator. So if we have two fractions that share same denominators, then we could just do it the regular way that we know. So what I could do, I could actually multiply this fraction here by 2. And so what we have 3x plus 4. Well, 3x divided by 4 plus 2 times 1 give us 2, 2 times 2 give us 4. And so we have common denominators, and this is what we always wanted. So we just bring back one of the denominators, and we just try to work out the numerators as they are. But if they are not like terms, we just bring them back in our answer. So let's look at another one. What if I have 2 m divided by n. So we could divide this by, let's say, n, then n, and we say 3m divided by 2. Now we could do this two ways. We could actually do the traditional way of finding the lowest common multiple, or we could actually try to convert or change or to find a number that when we multiply the fractions they share same denominators. But we could actually look at the lowest common multiple thing. When you have a fraction, when you have fractions like these though, to find the LCM, what we could do is to multiply the denominators as a product, and that will be our LCM. So what we could do, we could say 2n, and we will do the same thing as if we had regular numbers dealing with. So we say n divided by 2n, that will give us 2. So we take that 2 and we multiply by the numerator. So we say 2 times 2m, that will give us 4m. Or do the same, we do the same thing. So 2 into 2n, that will give us n. We take the n and we will multiply by the numerator. So we say n times 3m, that will give us 3mn. So since the numerators are not the same, then we just leave our answer like this. Let's look at another one. What if we had x divided by p plus y divided by m? Well, we do the same thing. We can actually use our denominators as product, and then we just do the same with that, and then we do that thing, or we just try to model the denominators to be the same. So we could actually say, let us try to do the product thing, where we say, okay, the LCM will be PM. And we say P into PM, that will give us M. So we say M times X, that will give us MX. And then we say M into PM, that will give us P. So P times Y, that will give us PY. So that will be our final answer. Or if we want to look at it in the other way, by trying to convert, try to let the denominators to be the same, what we could do, we could actually multiply this fraction by m, both the denominator and the numerator, and then multiply this fraction by p, both numerator and the denominator. So what we could do actually now distribute the variables that are outside with the variables that are inside the bracket. So we can say now m times x give us mx divided by m times p give us mp, plus p times y gives us py, and we could say p times n give us mp. And we realize that the denominators are the same. So since they are the same, we could just bring back one of the denominators and we just write back our numerators. They are not like terms, so we just write them back like this. So we actually ended up with the same answer. Let us look at this one now. If I have 3x divided by 4 plus 2, well, x2 divided by 3, and let's say plus same thing divided by 12. Now we could actually do this two ways. We could actually do this, finding the lowest common multiple, or we could try to find a number that when we multiply the fractions, they share the same denominators. So we could actually do that. What we could do, since 12 is the highest number here, we could actually we should actually work these two fractions, find a number to multiply both of them so they can have the same denominator as 12. So what we could do, we could actually multiply this fraction by 3. We could multiply this fraction by 4. And so when we do that, we have 9x divided by 12 plus 4x, because 4 times x give us 4x, 4 times 8, 2 give us 8, and 4 times 3 give us 12, and we just write back the fraction that we are trying to model. And now, since each fraction has the same denominator, we'll just take back one of the denominators. So we just group like terms. So the like terms are 9x. So we have 9x plus 4x plus x plus 8. So 8 plus we had 2. And so we'll actually simplify this fraction, seeing that we have grouped them. So we'll say now 9x plus 4x gives us 13x plus an extra x, that is 14x. And then we say we add the constants. 8 plus 2 give us 10. And then have it all over 12. But we can actually simplify this some more, seeing that each number, well, the coefficient of x and the constant 10 and the denominator 12, since both of all of these numbers are even numbers, and they will actually share at least a number, or well, the highest common factor that can be divided into all three. So we'll actually do that now and to simplify it. So we'll actually be writing an equivalent fraction for this fraction in its simplest form. So we see that 2 into 14 goes 7 times. 2 into 10 goes 5 times. 2 into 12 goes 6 times. So final answer will be 7x plus 5 divided by 6.